Good afternoon.
Good afternoon, everyone. Myself, Lukesh Kadu, Assistant Professor, IT Department, Shankar Kachi Engineering College. Welcomes you all on the 5th day, session 2 of AICTE-ISTE sponsored 1-week online refresher program on developing secure IoT applications organized by IT Department, SAKEC. It's a great pleasure for me to introduce our esteemed speaker, Ms. Gita Gosavi, ma'am. Ma'am, she is Principal Technical Officer, CDAC Pune. She has extensive experience in engineering and management, research and development. She is expert in leadership and mentoring, test and problem solving in research and development industry. She has done significant study, analysis, capacity building, and implementation in upcoming third area of IoT, which leads to production capability for smart city applications. She is actively involved in stakeholders communication, solution designing, and project coordinations. Thank you so much, ma'am, for joining us today. Today, the ma'am is going to enlighten us on the topic of IoT middleware and system design, a holistic approach. So now I would like to request our esteemed speaker to start the session.
Thank you very much, sir. Okay, so first of all, I really apologize. I hope I'm audible well to
Yes,
all of
ma'am.
you. Yes, so first of all, I really apologize for this small glitch which we had basically over the meeting room here, because the meeting rooms are quite occupied, and I wanted a bit of silence. I'd booked anyways, so I'm through it. And so as sir has given a very wide introduction, I'll straight away share my screen and jump to the presentation. Is the presentation visible?
Yes, ma'am.
Okay, okay.
Ma'am, can you just minimize that small window?
Sure, I'll do that. Yeah. Okay, so I think it's fine now, right?
Yes.
Okay, so I think this whole program, the short-term training program, has begun on 2nd, and so today most of the participants which we have here might have already understood a lot of concepts which are related to IoT as well as the security aspects of it. I went through the agenda of your complete session, and it has a very good coverage in terms of various hands-on session as well, which are included. So I'm sure today when I take this particular session on IoT middleware, where you already have an idea of the northbound and the southbound interface of this IoT middleware. So basically, when I mean by the northbound interface, I mean the various IoT applications which are developed for the end users. And when I say the southbound interface for IoT, with that, I mean various devices which connect to this middleware. So the middleware is something which sits between the northbound and the southbound interface. And the agenda behind choosing this particular topic is because not all the time when you develop an IoT solution, you end up developing every piece in a silo, right? So you need something which will be a layer which will sit in between. It is the same way as we use the operating system on our computer, right? So with the operating system solves the complete issue of interfacing with the hardware in the system. So similarly, the middleware will provide a great kind of abstraction in terms of the southbound interface, which are the sensors, and the applications. So it solves this whole juggling between understanding of the sensors separately and understanding of the application separately. So you need not bother about all these things with the abstraction which the middleware provides. So that is the basic reason. The second reason behind choosing this topic is because at C-DAC, we have developed our own IoT middleware in around year 2013, when this IoT market was quite upcoming, So that was the time when the middleware project was also completed. So, well, I don't have a very big corporate presentation here, so I won't tell you much about CDAC, and I hope all of you already know that it is a premier R&D organization of MITI, which is Ministry of Electronics and IT. There are two branches. It branches out into two things. One is C-DAC as a finishing school, which most of you know it is an academic organization with multiple courses happening. And it is also a R&D organization, which has changed to IT and IT-enabled services kind of organization over a period of time from only R&D. So now there are various business solutions which are developed at C-DAC against client necessities. Okay, so these are the two branches. Of course, I'm a part of IT and E branch of C-DAC. And many of you know C-DAC with the high performance computing initiatives in terms of the supercomputer, which was rejected, by Cray and then later on developed in C-DAC. So that's a very huge dimension of C-DAC per se. However, in addition to this, as you can see in the image given there are many other verticals in which C-DAC works into, right from language technologies, right to e-learning. There are health informatics solutions, along with high performance computing. We work in grid and cloud computing, right? And of course, professional and VLSI services as well. Lots of open source and web technologies are also developed, similar to the IoT framework which we did, and of course information security. So it branches out into all these things. So approximately there are 12 C-DAC centers all over India with approximately 3,200 employees, okay, to be specific. So going to the session outline, so we will be looking into IoT middleware aspect, with starting with various layers of IoT middleware, and then from middleware, after briefing a bit about a middleware, a generic IoT middleware, I'll be going into specifics of the security aspects which you have to deal with in an IoT middleware. Then comes IoT ethics. Okay, so when we want everything to go to internet, or when we want everything to connect to internet per se, there are a lot of things which we have to think of. So that is something, and what are the challenges while doing so? What are the things or precautionary measures which we have to take care of will be covered in the second section of the complete session. And I have a brief section on IoT system design, which is basically not related to the purview of your whole STTP, which is developing secure IoT applications. But since the first and the last word say developing applications, okay, so the first word is developing and the last word is applications. So let's keep IoT away for a while. So what are all the things which you have to think of, which is a design thinking, which we call it as, when you develop an application? So I just want to take you through this particular part, okay, so that what things you have to look for into when you change the application to an IoT application. So that will be covered in here. So moving on to the first part, which is IoT middleware. So, a very good quote by Jeff Bezos. So if you build a great experience, customers tell each other about that. Okay, so that is what IoT middlewares are, because if you are able to build something which will act as a software glue, as defined in this slide by Gartner, the middleware is a software glue. So it's a software glue, okay, that helps the programs and the databases, which may be on different computers. It helps all of them to work together. So its most basic function is to enable communication between all these different pieces of software, right? So that is what this middleware is all about. And even if you go for a very basic definition of IoT middleware, so it says that the software acts as a bridge between an operating system and or the database applications, okay, especially on a network. Okay, so I have highlighted the terms which are important here. So it acts as a bridge between an OS or a database and applications. Okay, so that is what I told you earlier. So if you look into the various architecture layers of a middleware, so starting from bottom, let's go from the southbound to the northbound. So you have sensors, connectivity, and network. So at the bottom most layer are various sensors, which are like sensors, actuators. You have these RFID tags. You have temperature sensor, humidity sensor. You know, I know you all have been listening all a while in last few days to all these terminologies and very well appraised with it. So I'll not go into depth of it. And then there are gateways. There is network, which comes in between. There are various communication protocols. I'm sure you have gone through protocols like MQTT, you have gone through CoAP, and of course XMPP, and there are so many protocols, even the normal, sub-gigahertz and gigahertz band with Zigbee, Z-Wave. So all these protocols will form a part at the gateway and the network layer. And then there are management services. Okay, when I say management services, they are for the device modeling, configuration, and management, because you have so many devices. If you consider a single IoT application, a siloed application, you might be having hundreds and thousands of devices for that application. And if you consider multiple silos which are sharing information with each other, imagine the management which you are going to require. For that purpose, there are management services. And at the top, of course, there are the best thing which every user likes to experience are the IoT applications. Endless list like environmental, energy, healthcare, retail, people tracking, surveillance, and so on and so forth. Let's try to break each layer, starting from the bottom layer again. So as I have said, it's sensor connectivity and network layer. Okay, so here, why the network layer in gateway as well as in sensor connectivity is because both of them need some way to communicate. Okay, so that is the reason there it is said as sensor connectivity network layer and gateway and network layer. So in sensor connectivity and network layer, so you can see various technologies, an array of technologies for sensors, and of course sensors, actuators, both are the southbound interfaces, right? Because the whole communication or the protocol stack is followed from top to bottom and from bottom to top, right? So it's a two-way communication. And then we have like various tags. So all these technologies are listed here from 6LoWPAN. Wired also comes as a part of it. In gateway and network layer, we have various gateways which are going to do this protocol conversions or protocol transmissions, or just use the underlying protocol in order to transmit the data, and so on and so forth. So GSM, UTS, WAN, as well as LAN. So that way it has been categorized in the next layer. In management and services layer, as I have talked, there are multiple business services which are developed at this layer, which will help you in data governance. There will be some sort of data repository which you will have at this layer, where the complete IoT application related data will be stored, and you will be doing a lot of data analytics with using services at this particular layer. When going ahead, there will also be, with the upcoming technologies like blockchain coming up, if in case you have to integrate it with Internet of Things, the management service layer is what will provide you the APIs in order to do the integration. Okay, and then of course the application layer, which is at the topmost part of it. Yeah, so there are a lot of industry partners. Excuse me. I have booked the room till 3:30 and my space is going on. There are a lot of industry partners. There are a lot of industry partners which are involved in the whole structure. So you can see very popular names here. I'm sure you might have used a few of it, like, you have ThinkSpeak, and I'm sure you have used, because these are some open source, third-party APIs which are provided by all these things. And then you have Veiw, you have iCore, you have Linksmart, and then there's IoT, Butler, ThinkWorks, and so on. So these are various industry players in the middleware market, okay, in the middleware market per se. So why I'm highlighting these names to you is because when we developed this IoT middleware at C-DAC, these are the things which are open source middlewares, which were also used as references in order to understand the complete API documentation, right? So now, coming to the security aspect of it, I'm sure the middleware part is clear to a greater extent. So coming to the security aspect of it, there are a lot of potential threats. Okay, so when it comes to middleware, do we have a compromised IoT device? Is a question which everybody might be encountered with, and whether there will be some leakage or misuse of the personal information. So these are the potential threats. So when you consider any IoT application, because you are generally connecting directly to the internet, whether there will be leakage or misuse of personal information is something which you have to look into. And then whether there is a threat to people's physical safety, okay? Because say, for example, consider a smart home kind of an application and consider a sensor or an actuator which is compromised. Consider an actuator which is compromised and somebody has the control of it. And for example, that particular person is taking the control of your actuator, say, which is connected to a water heater. Okay, and on taking that particular control, he turns on the water heater, which you are unaware of, and when you reach home and when you try to take the water, it is a difficult scenario, right? So these kind of threats, threat to person like this, there might be multiple n number of applications and use cases which you might think of where there might be a threat to people's physical safety. Now, going from the constrained devices, because I'm sure you might have seen there are types of devices, that is constrained devices and unconstrained devices. So in IoT, what we are majorly dealing with is the sensors and actuators, which are basically the constrained devices. Okay, so these constrained devices are incapable of performing heavier cryptographic algorithms, right? So we have a lot of things. We have RSA, we have so many cryptographic algorithms for key management, we have many things, but we cannot use all these things as is, okay? So we have to see how we could customize it, modify it, and then try to use it. Now, when it comes to the whole IoT scenario, mostly we will be going wireless, right? So another threat could be eavesdropping and jamming, okay? The very popular terminologies of security threats, right? So these are various potential threats which could come. Now, when we see the adversary of all these threats, so you can see this particular image here where there are multiple siloed applications, however still connected over the internet. So you have a smart home application, you have a smart grid application, and you have a smart healthcare application, right? And each of the application is going to have its respective gateway, IoT gateway, which is going to send the data over to the IoT server. And of course, the IoT, when I say smart home application, they have their respective middlewares, okay, with them. Now, when you can see the IoT server, and of course, in MQTT, I'm sure you might have come through concepts like publishing and subscribing, okay? So now what happens is, in this particular scenario, say for example, at the left top side, if you can see, so the adversary acts as a false application attempting to access the information which is not intended for it. So this could be, one potential threat. Then at the bottom, you can see it alters the sensor to report a false reading. So you see the array of, possible threats which could compromise the complete scenario. That is the reason these threats are to be dealt with at that particular time, right? Then the adversary attacks communication conduit between the server. So, okay, so the communication channel itself is compromised, right? So what to do in that particular case? Now, the adversary monitors sensor readings to track customer usage. So what is the customer usage? So the sensor readings, say, for example, in a smart grid application where the electricity consumption is being monitored, right? So in that case, what if the sensor readings are again changed? Nowadays, we have been listening to a lot of news in terms of lakhs of bills which are coming, right? So, of course, a middleman would not like to face such kind of scenario at any particular time in his or her life. So, however, we are slowly again moving to the smart grids. Okay, so slowly the whole infrastructure will be changed as we are moving on to smart city implementations today. So we are looking forward to smart grids. However, at the same time, you have to think of all these threats, and then it creates a spoofing sensor to the system. So again, some sort of eavesdropping which is happening in the system. So all these threats are there, and hence now what is the security taxonomy when it comes to the IoT middleware? So in security taxonomy, what I mean is in security, there are two parts. One is the region of attack, and then what are the security requirements? So how exactly you can overcome all these things? Okay, so otherwise you will say, a man came and she told all about threats and how are we supposed to deal with it. So of course there are solutions which are available in the market in order to deal with all these complex scenarios. So let's first see the problems and then go to the solutions. So when you see regions of attacks, the regions of attacks could be on the entities, could be on the data. Entities, with entities, what I mean is the sensors, the actuators, the gateways, right? So the applications, middlewares, there are devices. So these are the entities. Then it could be on data. The data is either the stored data in the database or something which is transmitted over the communication channel. Because of course, when it comes to IoT, we are thinking of real-time applications, okay? Or at least we are thinking of near real-time applications, right? So something is being transmitted all the time. Then we have a communication channel, right? So in communication channel, the channel could be between applications middleware, as I have said, northbound and southbound interface, or it could be between devices and middleware. Okay, so there are two communication channels which are given here. So what are the security, what are the solutions to these things? How do we go about it? So we should have proper authentication, we should have authorization and access control, we should have the complete communication channel protection, there should be data confidentiality, data integrity. These terms are not new, and we have been listening to all these terms throughout our lives since we possibly passed out of our engineering, most of us, or any sort of graduation, and have touched upon security at any point in our lives. So the same things are to be very meticulously followed when it comes to IoT middleware or developing any IoT application for that matter. So as I have said, as I have shown you a middleware market earlier, in which one of the major players was IoT-A. So IoT-A is a European Union project. Again, it is an open source project, and excuse me, it mainly deals with providing this architectural reference model, or ARM. Okay, so it's as the name itself says, it's basically a reference model which helps you develop your own middleware, and you can use their documentation and go through their deliverables in order to understand what are the requirements or the feature list which you should have in your middleware. So as you can see in this image, this is basically the architectural reference model with management on the left-hand side, security spanning across on the right-hand side, devices at the bottom, applications at the top again, and then we have communication, service organization, IoT process management, virtual entity, and IoT service, lying in between. So let's try to dig into each block one by one. So the management is, of course, these are called as functional groups. Okay, all of these are called as functional groups. So the management will address the interaction between all these functional groups. It attends unexpected issues like DICE link failure or some sort of queue overload. Also, it provides a lot of flexibility, okay, in terms of handling changes in use case requirements that again are catered by management. Fault handling, that is detection of existing failures and repair, is one of the roles which is played by this functional group. Service organization, I don't have to go into much depth here because possibly this might not be a complete purview because we are more concentrating on security, which is on the right side of the whole middleware. However, service organization would be mapping of the services. So when you say it's a microservice architecture, right? So here, when you say it's a communication hub for all the functional groups, so it composes and resolves services. So when you say get sensor data for me, so that particular service of getting the sensor data, it's a web service, right? It's a get service, which is web service. And like this, there might be hundreds of services which will end up writing for various functionalities for a middleware, and all of this will be handled by the service organization. Okay. Now, it also helps in building services and applications on the top of IoT. Now, what are these IoT services? IoT service is any service which you write, right? So it helps in discovery, lookup, and name resolution of IoT services. So which sensor? Okay, so what is it that you are referring to is something which this functional group will give as a pointer to. In virtual entity, every sensor which you have will have an identity in IoT middleware as a virtual entity. Okay, so it will be converted into a virtual sensor when it goes to an IoT middleware. So this particular virtual entities are being taken care by the virtual entity part of the middleware. At communication, I don't have to tell you because there are plethora of technologies, few names which we have already seen in our earlier slides. So security. So the security helps in addressing trust, security, privacy, repudiation, and all terms which you may think of. Process management is again the business process management, something which is quite outbound, directly dealing with the application. Okay, so it relies on the service organization functional group, and hence the arrow you can see from service organization to the IoT process management group. Right, it provides additional extensions to various industry standards. So for example, about OPC UA, or so basically middlewares are in order to make things generic. Okay, so middlewares are not specific to a particular application. However, when the end user comes with a need of smart grid, where he might be dealing with protocols like Modbus and so on, so that is where this business, the process management layer will play a role, right? So it will help in understanding what all integrations are required for that particular use case, right? There is one popular middleware which is known as Linksmart. It was also known as Hydra earlier. So there are two names for this, and I thought of bringing this case study to this platform because this is basically the architecture on the left hand side, which you can see is the architecture of Linksmart. So there are again similar way as I have shown you for IoT A. I'll also show you the design of a C-DAC IoT middleware in upcoming slide. So as you can see, there are again multiple layers stacked above each other when it comes to middleware. This is what we are looking forward to. So from here you can see there is a network and security layer at the right hand side, which has this BGW, which is basically IoT border gateway. Okay, border gateway. So it's like some security person which is standing outside your company, or it is like some security person who guards the gates of your society. Okay, so this is what this border gateway does for the complete IoT solution. Okay, so there is a border gateway, and for networking there is a broker, which I think you might have done hands-on as well with a lot of MQTT brokers like Mosquito or RabbitMQ and so on and so forth, which are available in the market. The rest of the things I have though elaborated are not much of an interest here. However, they span across the complete middleware. Okay, so digging more into the border gateway part of it, which is given here in this particular image. So you can see here the left hand side block is basically the border gateway, and then you have any IoT autonomous IoT system which is trying to connect. So any outbound request is handled by three things. One is the HTTP proxy, the MQTT proxy, and the WebSocket proxy, because the request, any request which comes in could be categorized into either of these three things. Okay, so any external interface which comes over, let it be MQTT or let it be over HTTP, that interface has to go through the border gateway. Okay, so that is what is very clear in this image here. And then you have this OpenID Connect provider at the bottom between the border and the autonomous system, which you can see. So basically OpenID is again another open source implementation. We will see more about it in our next slides, because this will help in authentication and authorization. Okay, so when I have shown these things to you here, under security requirements, how to handle authentication, authorization, access control. So I'm giving you the solutions in order to do that. So when you come to this image, you have this OpenID connection provider, which is an open source implementation with complete code available on GitHub, which you can directly use in your implementation. Okay, so let's dig a bit more into this. So when you see this border gateway, which is Linksmart border gateway, for example, so the border gateway can authenticate and authorize access to HTTP, MQTT, WebSocket services. Okay, so which is clear in this particular image for the users. What is OpenID Connect? So it allows clients to verify the identity of the end user based on the authentication performed by the authorization server. Okay, so what it does is it will help the IoT solution which is working. It will help it to send a REST request in order to get a profile, basic profile information about who is trying to access. So it's a sort of a code between the IoT solution and somebody who is trying to connect to it. So that is the beauty of this border gateway. Okay, so coming to the technologies, if you see the OpenID Connect, then there are two implementations, popular implementations of this. One is Keycloak and one is the Auth0. Okay, so these are the Keycloak is basically for local deployments, and if you want to move to the cloud service, you have Auth0. So these two things are used in Linksmart and are used in many other popular middlewares in order to achieve the authorization or authentication, and these are OpenID implementations basically. Okay, now the second thing which you have to do, and this comes at the communication side, is to use TLS certificates, right? So we already do that. We have this SSL TLS certificates. So there is a company called there's an implementation called Let's Encrypt, so which creates these TLS certificates, which you can integrate with your IoT middleware solution or your IoT solution for that matter, and you can have this certificate creation, which will add an additional layer of security. Now, after that, what comes is, you have seen this small block here in this image, which is Redis, which is there at the bottom, right? So this is nothing but a sort of, you could simply call it as a database, but the database only stores the information in the form of key value pairs. So generally what you have is username, and then what is the username, or let's say password, and what is the password. So there's a key and there's a value to it. So when the information, mostly the access tokens which you have, are going to be in this form, right? So that is where you can use solutions like Redis, again an open source implementation in your solution, and it will help you in caching the access tokens as key value pairs. Okay, so based on all our study of various IoT middlewares available in the market, and finding out the best out of those middlewares, this is the simplest yet complex kind of an architecture which we came across. So here, as I have said, the southbound would be the devices and the gateways. There's a communication layer. Again, you can see at the right hand side, you have security, in which you have authorization, authentication, identity, key management, trust and reputation. And here again, there is service organization layer, management layer, event processing, right? Notification and alert with a good rule engine, which will support if this, then that kind of scenarios. Okay, and there is a web portal, and there will be some report generation and analytics, which is the most important key aspect of any application. Okay, so this was the IoT middleware, which architecture, which was developed using Node.js and MongoDB as the backend, and there were various node package modules, npm modules in Node.js, if you are familiar with the concept, which were available. There were modules for authorization, authentication, a lot of things were there for security aspects as well. So those were integrated with the IoT middleware, and that is how the middleware was created. Now, when I have said that we already know RSA, we know AES, there are so many encryption things and the security things which are available in the market. However, you have to customize them, and either if you don't customize them, there are things which are available already, which you have to think of using. For example, AES CCM. So which is an operation mode of AES. So advanced encryption standard, very popular, which we all know. However, directly instead of using AES, we can use AES CCM, which is an operational mode of it, operation mode of AES. Okay, so it is especially for the constrained devices. Okay, because IoT is equal to constrained devices, and then it provides privacy and authenticity, and it is provided by default with Zigbee, that is 802.15.4 standard. That is the reason Zigbee gained a lot of popularity when it comes to smart home application and many such IoT applications. The next could be the TLS, which is the certificates, which I have said. So it's connection oriented client server kind of communication, and it handles privacy, authentication and integrity. So step by, brick by brick, we are trying to bring all parts of the security layer or the functional group. We are able to cater to each sub part of it. Okay, so again, TLS uses AES for symmetric, and for RSA, again, we all know for the asymmetric schemes, right? And we all know the HTTPS implementation, so it's always advisable. It is one of the guidelines to go for HTTPS instead of HTTP, right? We know this technology, OAuth, and I think we all have been using it almost every single day when we install any application on the Play Store, right? So when you say allow access, so what works in the background is OAuth. You are trying to basically install a third-party application. However, for sign-in purpose, you say that you have to use your Gmail account. So how does it do that? So it does it over OAuth, and that is an open standard authorization, a very popular one we believe in, which has set its standards in market today, and it provides access to various resources only to the extent allowed by the owner. So you have to be very cautious when you press the allow button, and it helps in authentication as well as authorization, right? So now, if we try to compare various middleware systems in terms of various requirements which have been captured, so what you see on the left-hand side, or I could say the y-axis of this table, are popular middlewares. You can also see Linksmart as one of the middleware in this list. In addition to that, there are OpenIoT is another popular middleware. You have XMPP. So all these middlewares, if you type a term middleware, you'll be able to see most of this. Okay, most of those which are listed here. Now, you can see the requirement number 3. Okay, so which is a fifth at the top of the table, which is authentication. So authentication is almost addressed in all the middlewares, right? So which is a basic and very simplest thing to do and has been addressed. Similarly, access control is addressed in most of the middlewares. Integrity and confidentiality is addressed in most of the middlewares. Now you see few of the requirements like, secure device identity, right? The requirement from the top, it is 7th, right? So if you see secure devices, a device identity, it is only addressed in Hydra or Linksmart and Webinars. Right? So just 2, we can literally count in which middleware this requirement has been addressed. So likewise, there are few requirements which are addressed in very few middleware systems. Okay, so there is a lot of scope to work in this particular area and to improve the security, and that is the reason I've just tried to bring this slide up. Okay, so I think I'm ending the first section of the whole session, which was into IoT middleware, and these are the references which were used for the whole thing. Moving on to IoT ethics, which is the second section. Okay, so when it comes to IoT ethics, there is another quote which is given here. So what does ethics mean? So ethics means knowing the difference between what you have a right to do and what is right to do. Okay, so one is having a right and one is what is right to do. Okay, so when there is a thin line difference between these two things. So if you consider an organization, whether asking for leave in an organization is a matter of right or not, say this is one thing. In the similar way, when you say that you want to deploy a sensor in company premises, which will monitor the temperature in this particular room where I'm sitting, it is a temperature sensor which will monitor the temperature and which will adjust the AC for me. At least when you think of an organization, it could be a matter of right, whether having such a sensor, whether it is advisable, whether it is okay for, health of everybody, all the employees in this organization. And there could be many such examples where you might think whether it is right to do this particular thing in IoT or not. So that is the reason IoT, I thought of including IoT ethics, because just because the technology has come up in the market, you cannot go left and right about developing that particular technology and deploying it as per your wish. Even for that matter, developing it for your clients. So it is essential that you educate the clients as well about the ethics and the kind of things which may be done or which are right to do and which may not be the right thing to do. So if you see some of the distinctive features of IoT, so these are the defining features of IoT. So these are few keywords which have a great say when it comes to Internet of Things. So one is ubiquity and pervasiveness. So what does it mean? Is it has been ubiquitous and it is in existence since, and it's everywhere, right? It's pervasive. So it's there in our lives, let it be our offices, let it be homes. So the ubiquity and pervasiveness is one of the defining features of IoT. Second is the miniaturization and invisibility, right? So today we are thinking of having a sensor of we have already had in our wristwatch and all, we have already have the sensors. They're thinking of putting a sensor in our eyes, the way we wear the lens, okay, on our eye. So similar way they're on the retina, similar way they're thinking of putting a sensor there so that it will for example, you're watching today when we think of this COVID world, we have our kids, which is a major problem, kids watching the television. So if it's being sensed, what is the kind of damage it is doing to their eyes in terms of whether they'll have specs in near time, what is happening exactly. So the research is already happening in terms of having a sensor. So think of the miniaturization which it has to go through, and in addition to miniaturization, think of the how it is going to get energy, how it is going to be harvested in that particular sensor, how the energy harvesting will be done. So the miniaturization and invisibility, then of course the other feature is the ambiguity and ontology, right? Because there's widespread of things. We are think of the semantic search which you have to go through when you look upon sensors. If I'm sitting in this particular meeting room in my organization, I have a sensor in order to control the ambience, the lights, and all these things of the meeting room, which will give me a smart office kind of a feel. If I go down in the parking, I have smart parking solution implemented, where I'll be able to see which parking slot is vacant and take my vehicle there and park it. Or if I park at the parking slot which is reserved, whether I get an intimation on my mobile phone. Now, in addition to that, there is another solution which is a safety solution here, where there are a lot of fire alarms, and all these things. And so that is another silo. So in one building, you can think of so many solutions, IoT solutions. And if you have one single middleware which is handling all, which is catering to all these different use cases, 3 to 4 of them, you can think of the ambiguity and the ontology, which is to be taken care of. And that is the reason there are lots of functional groups which are defined. So that is another defining feature of IoT. Identifying, of course, very important. Every sensor is critical. Every actuator is critical. So the proper identification, connectivity, another important thing. Of course, this differs from use case to use case. Okay, then mediation and autonomous agency, right? What are the mediating agencies between various IoT? One IoT application will have multiple mediation agencies playing a role. Embedded intelligence and extended minds, a seamless transfer of information, let it be a seamless transfer of information or the data which is going to flow. Then the distributed control, big data. There's no control over the data which is being generated, right? And there's a lot of unpredictability and uncertainty when it comes to IoT. Okay, so after the defining features, what are the ethical challenges in IoT? So the first very common question anybody will have is, who is the owner of the data retrieved by the sensor of the objects connected to IoT? It's not only related to IoT, it's a generic issue, right? So when we say I'm using Gmail, or when we say we are using various social networking platforms, this is a generic question which we have, is who is the owner of all of these things? Now, when it comes to IoT, it becomes still critical, because the data is something which could be of a very critical nature, right? It is again based on, let's consider oil and gas agency. There an IoT solution is implemented, or you could think of a healthcare domain where the IoT solution is implemented. Healthcare is very critical area, right? So who is the owner of this data which is retrieved by the sensors, and how to control the accessibility to the IoT system? Another thing is IoT only for experts? So, there's a great digital divide, because there is a chunk of people who absolutely don't know anything about IoT, though they have been using much of it, they're still not aware. So there is a great digital divide which is there. So is there no coherent legal or democratic frame? So there is no delineation of the limits of information sharing. There's nothing like a legal structure which is defined other than a draft IoT policy. I don't think anything has come from the government as such in terms of, these are the things which you have to follow. For example, when a sensor is nothing new, right? It is not something which came into market only for Internet of Things. It has been there since years. It is ubiquitous, it's pervasive, has been there since long. However, it has gained a greater importance today when we have thought of this IoT arena. But when the sensor is designed right at the hardware level, what are the guidelines or what are the legal best practices have been given to these sensor manufacturers, that considering what exactly is the information which they should gather? So this is one of is there any framework for it? The answer is no. So, or the answer is like it's not a complete one go framework which is available. Okay, so these are all the ethical challenges. Again, what about the economic incentive for data protection of the user, which are not directed to the user? So the user is unaware. If, say for example, the user volunteers to share data to the IoT application. Today there is a lot of crowdsourcing application. There are quite a bit of sensors in our mobile phone, right? There are accelerometers. Today we share the data from our phone to Google. In turn, it helps us in terms of defining the traffic areas, in terms of navigating us, in terms of telling us which restaurants are good, or in terms of gathering information from us, in terms of following us to take our location, right? Are we earning out of it? No. Okay? We are contributing to a better world today, to a better cause today, every individual. However, there is no economic incentive for the data protection or even the data sharing, which is happening today, right? Then the incomplete information on the consequence of data disclosure. If I disclose this data, I'm not sure how many of us even read the license agreement. We are very much used to take I agree and go ahead and install that application, right? So so that because though, and even if we read it, how much information is given, how much transparency is provided through that agreement? Okay, so there's still a question mark on this. There's too large information space about the consequence of data disclosure. So the information space is huge. So the complete set of needed information to make a rational choice would be so large that the user may not be able to access the IoT service in an effective way. Okay, so a larger information space. That is the reason there's a lot of ignorance to it. Then there are psychological biases. For example, what do I mean by psychological bias is there are a set of people who don't like using Wi-Fi, which is a paid service. However, you make them sit at a movie theater or you make them sit at a railway station and give them a free Wi-Fi access, they'll immediately connect, right? And start using it without thinking of whether it is safe to connect to an unsecure Wi-Fi, right? So there's not psychological biases. Of course, it is provided, it is given for use. There's no question about it. However, do we even think of the security aspect of it? Okay, so it's a question. Then the trade-offs between businesses needs to collect and process the data and rights to privacy. So again, there is a lot of trade-off between these things. So whether it is being used, what are the regulatory bodies, whether the government is supporting, and all these things, there's a lot of trade-offs between the right to information when it comes to IoT and the right to privacy, okay? And the cost of implementing privacy enhancing or data protection solutions. There's a huge cost of implementing these privacy enhancing technologies, which is called as PET, okay? So the cost of implementing is ensure proper care in collection, store and retrieval of data. So who is going to support this cost is still a question. Who is going, whether the user is responsible in order to pay for this cost? Yeah, because the user is more concerned of his or her privacy. So whether the cost should be borne by the user or who will take care, or whether there is some political or a regulatory body which will be there in between will take care of this. So these things are to be thought of. Accountability, right? Who is accountable for IoT application regarding users' privacy? Again, I mean, who should we point to? So there is no single person, there is no single application which we can point to. Online and offline identity. So it is difficult to separate the online information from the offline information, right? And digital divide, we have already seen. There are a lot of regulatory frameworks. So whether they conform to these regulatory frameworks or not, and whether these regulatory frameworks are penetrated to the market today, okay, then there is a support for dynamic context. So the use of IoT services and devices for, again, for storing personal data is not recommended. Now, when we think of delineation of all these things, as I have said, you can see a lot of overlaps, right? So the cloud computing is overlapped with big data, is overlapped with mobile computing, is overlapped with future internet, ambient intelligence. So there's no strict boundary which we have among all these things, which in turn are the inbound technologies to IoT. Okay, now there are a few, again, listing a few ethical issues. To treat fairly all persons regardless of such factors as race, religion, gender, disability, age, or national origin. So do we have it today? Has internet reached every household? If not, again, is there a digital divide, right? So how to go about it? For the disabled or the differently, rather than calling them disabled, we can call them differently abled people. So when you are thinking of building an IoT solution, are you thinking of this differently abled, a big crowd which is there today? So that they should be able to use every IoT solution. Are we thinking of them? So I would like to state one example here under the IoT framework. As when we developed the IoT framework, we have developed an application which was navigation system, in-house navigation system in the premise or in the office premise. So where if a new person comes in and the offices are huge, so how to navigate that person? Here again, we specifically later customized that particular application to include the blind people. Okay, so it is not only a normal human being, they are still more capable, but what about the differently abled or the blind people? How to navigate them in an office premise? And consider the amount of the trade-off or the kind of accuracy which we have to achieve. At least for a person who is capable, we could, it is easily possible to tell that the door is on your left. But it's not the same case for a differently abled person. By telling him the door is on your left, and if the accuracy is not met, and if there's a wall on the left and the door, just 2 steps ahead, we cannot have that kind of inaccurate solution, right? So all these things are the ethical issues which are important, and we have to respect the privacy of others, honor the confidentiality. Should we assume that our lives and our behavior are being monitored at all the times? Is one question which any user would ask. Are we monitoring the lives or specific aspects of lives of everyone to reduce the risk of each of us? So all these things are to be thought of, and we have to deal with the things which are listed here: the social justice, the digital divide, the trust, the blurring of context, because we have no demarcation per se, and between the users, the regulatory bodies, and the legal implications of it, and so on and so forth. Also the agencies and the autonomy. Okay, so when we think of if you start going in deep for the social justice and digital divide, so human society on a whole follows social rules, manners, and etiquettes. Okay, so problems arising from unwanted data transfers may result into distress and even legal appeals. Okay, so the digital divide leads to knowledge divide. As I have already addressed, the special needs people like children, elderly, or even the differently abled people, what about them? When it comes to trust, there's no knowledge and what information is actually shared, and it is shared with whom. There is a fear of privacy infringement, right? So reliability issues are there. There are trust negotiations, so credential exchange in order to obtain the service or the resource. Should we do that? Should I allow a third-party app to access my Gmail credentials? Who has decided it? I have relied on OAuth for me to do that. However, do I really trust that particular negotiation happening between the third-party app and my Gmail or my Facebook or my LinkedIn for that matter? In Netherlands, so the Dutch government has planned implementation of smart meters, and later the case study became very popular, which happened in year 2010, when the Dutch government had planned to implement the smart meters, and they were considered as spying devices by the population, and there was a lot of reluctance. So why? Because it was said that the smart meters not only monitor the energy usage, however they also click the photograph of the house and send it across the communication channel. So there were lot of havoc which happened over this particular implementation at that particular year. So see the kind of trust issue which is happening, and people are skeptical in terms of sharing information. Now, blurring of context. So mediated environment. So there are a lot of things, as I've said, multiple use cases in the same building, like kitchen, living room, shopping mall, schools. So these are all the everyday environments. So now when we say that there should not be a divide in terms of having a solution here and not having a solution there. If there is a solution for a smart restaurant, it should be adopted by all smart restaurants. Why there is no clarity? Why there is no clarity? So for example, a smart meter in private sphere within home, which is storing information on private behavior, and in public sphere, it is, so you see the same device which is serving two different purposes. Okay, for private sphere, it basically tells me how much energy I'm utilizing and help me reduce the electricity bills and so on and so forth. However, in public sphere, it will help in fast, efficient and reliable distribution of electricity, right? So they are not bothered how much energy you're using. More you're using, better for them. Now, why they are not bothered about whether your electricity consumption should be reduced or so on and so forth, multiple things which are coming up. People tell you to wear a helmet. I don't want to wear a helmet. A blurring of context, right? I don't like wearing a helmet because there's a lot of sweat which happens. Okay, so there are multiple things, whether or multiple ethical issues which one might have to think of when one develops an IoT solution. Now, when it comes to agency, it is nothing but a social contract between people and objects. So the objects act and decide in invisible but intentional ways and on behalf of human users. So as I have said about the virtual entities earlier, right? So they are deciding on behalf of the users. The actions are not fully controllable by the users. So who is the agent? Is the agent a user or an object? So these kind of things are something which could breach the ethical space of an end user when it comes to Internet of Things. This is a very good cartoon example. Now, when somebody comes to you, say any regulatory authority, and tells you that we want to implant an RFID tag in you, the person will immediately say that no, that violates my rights. I don't want to do that. It's wrong. Why you cannot just come and implant an RFID tag in you. Now this same regulatory body puts the same thing in front of you in a different way. Okay, we want to implant this tag in you, and it is also a cell phone. It is also a digital camera, and it has an MP3 player. The same thing which has some additional features which are of interest, individual's interest. So the person will say, okay, cool, I'm okay, go ahead and implant it, right? So again, we are back to square one. So what should we do and what should we not do? So you have to have a very clear thought when you develop, and you have to abide to the best practices and the guidelines which are defined, and develop the solution in fence of those guidelines. Okay, so now when it comes to autonomy, which is I think the last part of the ethical issues, so it is to discern the key component of informed consent. So whether when you say I agree, when you accept a particular license agreement, you need to understand what are the ethical issues which are involved in this. Now, for example, miniaturization and invisibility leads to avoidance of any inspections, audits, quality control, and accounting procedures. Things are taken for granted and they are assumed to function properly. So any smart object can be perceived by user as an ordinary object. Okay, so when you, for example, when you come to C-DAC tomorrow as a visitor, do you, and there is a navigation application which you have to install at the entrance on your mobile, and you provide a consent in the agreement that you're okay because it will help you navigate inside C-DAC. Do you ever know the kind of sensors which you are coming across while you are here in the C-DAC premises for say another 3-4 hours? Can you actually point out a sensor here? No, because it will be just another ordinary object for you. You won't be able to pinpoint that this particular thing is nothing but a sensor, right? So that is the reason there is a thin line between the informed consent and just taking a consent, ordinary consent, which is just saying, okay, I agree or I disagree kind of. I don't think this is a major slide. Here I would just like to say that there are top 5 things consumers will fear, which will be misused by cyber criminals. Looking at India, if you can see the credit card and debit card information is at 80%. How many of you, regularly change the passwords? 77%. It's at the top second. The personal emails is at 70%. The national ID number, possibly now it will slowly start coming up. Your Aadhaar, your biometric are the next in queue. Your personal photographs at 69%, which you upload on. So these are the major worries which are there. Okay, so what are the actions? How should you go about all this? Okay, so you can see India, which is in light blue color. Okay, so in the first, the change passwords regularly, 57%. Okay, so you should do this. The actions which you should do in order to keep information on connected devices private is this one action. You should keep on changing passwords regularly. The necessity of doing it in India is up to 57%. Change privacy settings. Avoided using or logging into public Wi-Fi access points, the point which we have already discussed. Avoid storing sensitive or classified data on devices. Okay, 37%. Turned off internet enabled functions when not actively in use. Turn off your Wi-Fi router at home when you're sleeping, when it's not being actively used. It will avoid a lot of havoc. It will avoid a lot of health issues which might come through it. Security issues as well. Okay, so this is the preparedness. So I think we have summarized all of this. So the advantages of ethical design is it will overcome all of these things which so you have to ensure that you have a good ethical design. So what are the recommendations to do that? So one is transparency. So the vendor regulation and certification. Okay, so the systems, the hardware which you have, kindly get it certified. Okay, certified that it is the hardware which can be used. The energy meters, they should be certified, but it is not something which is a spying device. There are a lot of certifying authorities for that. Then you have to regulate the access. Okay, the public should be given information. Transparency should be maintained while the information is gathered from the public. Okay, and of course there should be a lot of research, and that is the reason why this STTP and we all are here for. So the research should keep happening on various IoT things. So as I've said, there are There are labs like ICSL lab, or there are FCC certifications which will certify the industrial devices, or the communication device, the gateways. I meant the industrial devices, the sensors. So that could be done. There is one policy-based approach, which is a software solution for middlewares, which is called a SAKEC IT. Again, this is an open source solution, and it helps in setting up the security policies. So how it does that? This is the framework of SAKEC IT. So it has this PEP, policy enforcement point, okay, and which will help in allowing and denying what should get into the IoT system and what should not. I think the next slides will make it more clear. So it's a policy. The policy decision point receives event notification from policy enforcement point. Okay, so the policy decision point and the policy enforcement point. This is the decision point at the bottom, and there's an enforcement point here. So it will receive decision from the policy enforcement point. It evaluates various security policies. It helps in doing that. This was a small prototype, which SAKEC IT is an open source implementation. However, we had done a small prototype for the smart home solution using SAKEC IT. That is the reason I've included it, so that you'll be able to understand how the ethical issues can be handled, right? And then the policy enforcement points are embedded in IoT system. So these are embedded in IoT system using standard techniques. So there are custom libraries which are given by SAKEC IT for this, and you can embed these things into the IoT system. Okay, so how it does it? See, you can see the SAKEC IT GUI. Okay, so here you can see very well defined rule model where it says that a particular sensor, what is the event, what is the condition, what is authorization. So whether it is allowed or whether it is not allowed. Now you can see allow for doctor role, deny access for heart rate. Okay. So what is the authorization, whether it is allowed or whether it is denied. So this way you can define the authorization for various sensors. You can define the authorization for various user roles which are present in your system. So SAKEC IT is a Java-based implementation which will help you do that. Now, how to go about the policy framework? So you can see the government is also involved here. There is generic citizen, there are certified bodies on the left hand side, there is an employee. Okay, so there is a government body and authority at the top, and then SAKEC IT like solution is also there, and there are IoT systems, and there are IoT device manufacturers. So the device manufacturers will provide with a concrete IoT system model, and what happens inside is with the help of a tool like SAKEC IT. There could be many other tools like this. However, this is being highlighted here. So we can have various policy templates which are defined. The inputs for building these templates is given by the government bodies as well as the authorities, which will do the validation, which will do and will see whether the certificates given by the certified bodies are accepted or not. So all these things will go as an input, and after that these things will be given to the IoT system, right? At the bottom, the policy distribution will happen to the IoT system, and the system is good to go. So this is how you have to do the ethical design of an IoT solution. These are my references for it. So this covers the second part of my presentation today. I think, yes, we have still 10 minutes of time. I'll quickly cover the system design. So here, so the design is nothing but the intelligence made visible. This is not related to security per se. So just relax and enjoy this part of the topic where, it's time to introspect. So are you a design freak? You are designing an application here, right? So an IoT application. IoT is something which is enchanted, which seems to be magical. So, you look at the solutions which are there, which were very popular ones in the market. So say, for example, the MapMe ad at the right hand side, the round wheel which you see here will based on, you will have an application in your mobile phone, and this particular device is sitting at your desk in office, or possibly this particular device is sitting at your home, and you have a set of locations which are fed. So your family will be able to, the wheel will automatically rotate when you reach at your workplace. I think this idea was inspired by the movie Harry Potter. And then you have this glowing stick, right? At the night, if you have to pick up the umbrella and there's, say for example, there's no electricity or the umbrella is somewhere outside in your courtyard and you have to pick it up, the stick will automatically start glowing once it detects your presence near it, okay, around it or near it, and you'll be able to pick up the umbrella or based on the environmental conditions. Then there is an auto alarming tablet bottle by Vitality. Okay, then there is an alarm clock which is aligning with the metro which is coming at the railway stations. If you have to catch a metro at 11, the alarm clock is automatically aligned with its locations and whether it is on time or not, so that if it is delayed, it will at home itself, it will let you know that your thing is delayed. So we design with a purpose, right? So, and what if there's no internet today? Nothing of this is possible. We cannot live in a world of no internet today, though we are already living in the world of social distancing today, which once we also thought is not possible. However, we never know. So there's a disclaimer here. So the IoT equation has this physical object and the controller plus internet will give you Internet of Things. So there's a lot of diverse application space, multiple hardware properties. The power access is not easy and there's a chip for every application, okay? So these are the IoT application space challenges, the diversity, the constraint, the power constraint, the memory constraint, right? And so what we need to look into is the network topology of IoT system. Okay, so there are simple nodes and there is a controller and a gateway. We know this. I won't go into the depth of it. So the device and sensor node requirements is it transfers small amounts of data. It operates on batteries for several years, right? So there are 4 ontological properties. There's a sensing modality, what it senses. There's a form factor, what is the energy source or the sensor lifetime. Is it battery powered? Is it self-harvesting its energy? What is the connectivity, right? So these are the device requirements which we have to look into. I'll not go into device properties much. Now going to the design principles. So you have in design principles, there's configuration and user interaction. So see this small device at the iPod, which was very popular one time when it was launched in the market because of the whole design, the scrolling wheel which it had. Okay, so the connected devices cannot be designed in isolation. If you have to have an IoT device which the users are going to use, through which you are going to sense the data, kindly have a set of people who will be commenting in terms of designing that particular device. There are small pieces which are loosely joined, and that is the reason why internet has flourished. And it's one of the other thing is first class citizen of internet. So these are going to be on internet. Never forget that. Now I am sure you have seen microcontrollers like Raspberry Pi or Arduino over a period of time during your STTP. So whether I should go for an 8-bit MCU with an ARM Cortex processor, I should go for a 32-bit MCU. So it depends. If you want intelligence, if you want protocol stack, if you want sophisticated algorithms to be put on it, and the applications are power constrained, you should go for a 32-bit microprocessor. So these choosing of these things and designing of an IoT solution will depend on multiple factors. For selection of the kind of connectivity, whether you should go for wireless connectivity or RF connectivity, I will directly go to this table. Okay, so which connectivity you should choose. So frequency versus free space range. So you can see here there are 2 ATmega processors which are compared. So you can see the frequency band 2.4, okay, and 915 megahertz and 2.4 gigahertz, right? So in this case, if you reduce the frequency, you can see the sample analysis which are picked up from a white paper which are given in the reference. So if you reduce the frequency from 2.4 gigahertz to 915 megahertz, the range will increase by 2.6 times. Frequency is reduced, however, the range is increased. Similar way, if the data rate is reduced from 1000 KB per second to 20 KB per second, the range is increased by the factor of 6 times. So it choose accordingly whether you want the free space range to be more or whether you want the data rate to be more. What is the requirement of your solution? So here you can see a scenario where there are smart meters, there is a collector, and there is a utility data center or an MSCB center, what we call it as, or MSCB EDCL center, which we have.
Sorry to interrupt, ma'am.
Yes.
Actually, we have a next session at 3:30.
Yeah.
So it's a humble request if you can finish this session on time.
Yes. I think I have quite a few slides to go, almost done. Yeah, I think I'll be able to finish it till 3:30. Not a problem. Will you give me another 4 minutes?
Yes, ma'am. Yes.
3 minutes to be specific. Fine. Okay, so based on, I was just saying that based on what you want, whether you want a good data rate, you can choose the sub gigahertz or the 2.4 gigahertz band, or you can use the combination of all of this. Yeah, so user experience, which is the most important part, though I think most of you are already aware because we all are the end users of some or the other applications. So you have to have the user experience in such a way that, you know, the users feel good when they are using the application. The device should be sophisticated. There should be no glitches when you know, you're operating with that particular device, right? So we have to think of the design, and then you can see this graph from least visible to most visible. So the UI design is right at the top. The platform design, the service design, the productization all come at the bottom of the model. Okay, so the UI design is something which is important and which is something which you have to prioritize. Okay, prototyping. So we all know that we have this we have the cycle of revisit the design flaws, change, iterate. Okay, and nothing without having such kind of breadboard kind of a structure where you have Raspberry Pi connected, you have an LCD screen connected. Unless and until you do this, you cannot get hold on IoT. That is the reason prototyping is important. We starts with sketching. Okay, so if you already are a Python programmer and familiarity with it, you can choose Raspberry Pi rather than using Arduino. So that is the reason why I have included this. And then there's a cost versus ease of prototyping. So the cost of Raspberry Pi is though on a higher side and Arduino is on a lower side. So based on all these things, you can decide what exactly you want and how much development efforts. So these things, the cost versus ease of prototyping. So these things are like inversely proportional to each other. Okay. After prototyping, it comes to scaling the whole solution to production. Okay, so you can scale it, change the embedded platform. So you have to think of all these things and keep them in mind before you prototype a solution. You can use a lot of things and third-party APIs which are already available, like Veiw, Twitter. You can use a lot of mashups which are available on the internet when you go to data analytics part. There are curl tools which are available to test the web services before actually going for the deployment. So these things can be done when you are going online and using some web portal. You can use services from ThinkSpeak in order to check the graphs from your sensor data, okay, and so on and so forth. Okay, so I don't think we can, it's required to get into business models. It is especially for the companies which are developing solutions, since you people are, the audience of this particular platform are mostly, you know, the faculty members. So There is hardly any business model which you people will be looking into because these are profit-making things. Okay, like Indiegogo, Kickstarter. So in how to generate the funds when we start. We have already seen the design ethics. Yes. So any general purpose advanced IoT solution is multifunctional, it's multi-stage, and it's multi-pattern. So this is something, 3 keywords which we have to think of, and these are given by Gartner, that these are the things which you have to take care, that the solution is multifunctional, it is multi-stage in terms of, when the event widens and when you are taking new decisions and actions, we should be able to integrate into that solution. I think that brings me to the end of my presentation. Thank you a lot for your time. I think I went 1 minute extra. Yes, sir.
Thank you, ma'am. Thank you, ma'am, for such a wonderful sessions. Actually, you cover a lot of nice points you covered related with IoT middleware layer functions, secure IoT middleware, IoT ethics, ethical challenges, and IoT designing systems. All that presentations are very much useful to all the participants. So thank you, ma'am, for such informative and enlightening sessions based on that IoT applications, secure applications development. Ma'am, just accept the small vote of appreciations, virtual moment on behalf of IT Department, Shankar Kachi Engineering College. And thank you, ma'am, for being with us. Thank you for joining for today. Thanks a lot.
Yes. Thank you all.
Thanks, ma'am. Participants, the feedback cum attendance link has been shared in your Q&A sections. Just fill it. And one more announcement, your next session is 3:30 sharp.